this question, we're asked to calculate the directional derivative of f in the direction of u at p for f of xy is equal to x squared times y to the third for the direction vector I hat plus j hat at the point p equals 1 over 6 comma 3. Okay, so a lot of information going on here. Let's make some sense of it. So first of all, this thing here, we'll get this in normal looking form, right? So this is a coefficient of 1 and this is a coefficient of 1. And I corresponds to the x coordinate, j corresponds to the y coordinate, right? So we have those two. So that's 1, 1. Okay, and then here's our point P. This is like A and B. All right, and then we have our function there. So let's write down the formula for the directional derivative. So that would be d sub u f of p, or of ab, right? That's going to be equal to the gradient of f at p, and then dotted with the direction vector over the magnitude of that direction vector, okay? So first of all, let's find, so we know this, right? We already know that. That's a 1, 1, okay? And then now let's find the magnitude of that v. So magnitude would basically, we're going to square both of them and add them together and then square root it. So we get the square root of 2. Okay? So now that we got that, now all we have to find is the gradient evaluated at our point P. So what is the gradient of f? So gradient of f is going to be equal to f sub x and comma f sub y. So the first one is going to be obtained by taking the partial derivative with respect to x of our original function. And the second component is we're going to get that by taking the partial derivative with respect to y of that same original formula there. Okay? So what we're going to get is that the the gradient of f is equal to, so when we take the partial derivative, we're going to consider y as a constant. So that's just going to stay there. We're going to bring that 2 down in front. So we get 2 times y to the third times an x, okay? And then we get, for the next one, we're considering y as our variable, so x is a constant, so that just stays there. We're going to bring that 3 down in front, 3x squared, and subtract 1 from the exponent on the y, so that'd be a 2, okay? So we get that. Now we'll take this last line and continue on the next slide. So we have that the gradient of f is equal to 2xy to the third, and then 3x squared y squared. Okay, so if we're evaluating this at point P, remember our point P was equal to 1 over 6 and 3. Okay, so if we're going to do that, then we have 1 over 6 and 3 down here. So we're going to plug in for every x we see a 1 over 6, and for every y that we see a 3. Okay, so 3 times 1 over 6 squared times 3 squared. Okay, so lots of 3's and 6's and even a 2 in there. Okay, so this is going to be equal to, let's solve here. So we have a 1 over 3 times 3 to the third. Then if we simplify a little bit more on this side, we get a 1 over 36 times 3 to the third, right? So on the next line we would get, so these can cancel out and we have 3 squared. So that first component is going to be a 9. And then over here we have, we can make one of these, so 3 to the third is 27. And each of these you can divide by 9. So if you divide the top by 9 and the bottom by 9, we get 3 on the top and a 4 on the bottom. So 9 comma 3 over 4. That's our gradient at that point. Okay, so now we're just going to use that. So we have, this is the gradient, f at 1 over 6 comma 3. Okay, and then we have the other information, which I will also write on the next slide. Okay, all right, so our gradient of f at 1 over 6 comma 3 was 9 comma 3 over 4. All right, the other pieces of information we had was that v was given as 1, 1, and the magnitude of v that we found is square root of 2. Okay, so let's plug this in for the formula for the directional derivative. So we have that equals our gradient, right? And then we're going to dot it with the v vector, and everything is over the magnitude. Okay, so this is going to be equal to 9 comma 3 over 4 dotted with 1, 1, and this is all over the square root of 2. Okay, so what I'm going to do is just move that square root of 2 out in front, square root of 2, and then we'll calculate inside here. So we have 9 times 1 plus a 3 over 4 times 1 going on in there. So then if we simplify a little bit more, I'll just try to continue it over here. We'll try to finish it up. So 1 over square root of 2. And then we have times what? So we have a 9 plus 3 over 4. So that would be a 36 over 4 plus a 3 over 4. So that's the same thing as saying 1 over square root of 2. And then times 39 over 4, right? So you could just like leave it as this, or I'm just going to multiply times that radical 2 on top and bottom. So 39 square root of 2, and then that'll be over an 8. Okay? All right, so that is the directional derivative for that problem.